Okay, question 9 is, by looking at it, it's a 6-mark question. It's got some information, it's got some graphs, and I would look at this one. It's got a lot of space, which might put you off a little bit, but I would look at this one and think it's one of those leveled questions where you get level 1, 2, and 3 responses. So you've got to really kind of dig down into what the command words are asking you to do. So let's just have a look. So there are several stages in the industrial production of methanol from methane. The first stage involves a gaseous equilibrium between the reactants methane and steam and some gaseous products. Figures 1 and 2 show the percentage conversion of methane into gaseous products under different conditions at equilibrium. So we've got figure 1, which has got temperature and the percentage conversion of methane at constant pressure. And we've got a graph that does that. And then figure 2, we've got pressure, and we've got the percentage conversion of methane at constant temperature. Essentially, we've got figure 1, which is changing the temperature, figure 2, which is changing the pressure, and the question says deduce. So that basically means work out the optimum conditions, the best conditions for the industrial conversion of methane and steam into gaseous products. Explain your deductions. So essentially what I've got to do is talk about what happens when I change temperature, what happens when I change pressure. So temp, pressure. So what happens to the equilibrium? What happens to the yield of what am I making? Methanol. And then I've got to talk about optimum conditions. Okay, I've got a lot of space to do that in. I'm not going to need to take up that much space at all. So I'm just box that little thought process or plan off. I'm going to basically bullet point this. So I'm going to start off talking about temperature. So I'm going to say increasing temperature increases the yield of methanol up until after, I'm going to say 820 degrees Celsius. Okay, so that first part of my graph, I increase the temperature, I increase the yield of methanol quite significantly. This part of the graph starts to, the increase in temperature starts to not have a big impact on the yield of methanol, and then it starts leveling off. So after about 820, if I increase my temperature anymore, it's not really going to do much good in terms of the yield of methanol that I'm going to produce. Next, I'm going to talk about pressure. So if I have a lower pressure, look, if I've got a lower pressure, I get a higher yield of methanol. If I increase the pressure, the yield of methanol actually decreases. Okay, so I'm going to write a sentence that says, or a bullet point that basically says that. So the yield of methanol decreases when pressure increases. Okay, so now what I need to do is talk about what I would choose in terms of the optimum conditions for the process and say a little bit about each. So I'm going to say that the optimum temperature is 800 degrees C, and I'm going to say because the yield is high at a higher temperature, the yield does not increase significantly. In fact, the yield remains constant above 850 degrees C. Okay. Then I'm going to talk about pressure. I need to be careful about pressure, because if the pressure goes too low, that means my rate of reaction is going to be really slow, and I've got to be careful there. So I do need a fairly decent pressure so that my rate of reaction's okay, but I don't want it too high because that's going to decrease the yield, and it's also going to be expensive as well. So what I'm going to say is low pressure may result in a slow rate of reaction. So the pressure of 1000 kilopascals could be used. This produces a high yield of methanol. Okay, and essentially, if I look at the mark scheme for this, I don't really need to write any more than that. So I basically get a mark for saying increasing the temperature increases the yield until after around about 820 degrees C. I get a mark for saying that the yield of methanol decreases when the pressure increases. I get a mark for suggesting an optimum temperature that's around about 800. It's around, the mark scheme says about 750 to 850, I think. I get a mark for talking about the pressure, talking about a slow rate, and then talking about it having a an optimum pressure of about 1000 kilopascals as well. So a couple more marks for that.